Explorer 1, the farthest human-made object in space, has transmitted usable data back to Earth, a remarkable achievement that defies previous assumptions and raises questions about what lies beyond our current understanding of the universe. NASA's leadership has cautioned that Explorer 1 is set to pass beyond Neptune, evolving into an interstellar spacecraft that will wander through space indefinitely. For nearly 50 years, the Explorer missions have provided some of the earliest and most remarkable views of our solar system. These missions have exceeded expectations, despite initial doubts about their longevity. In the 1970s, scientist Michael Minovich proposed an innovative idea. A spacecraft could harness a planet's velocity to propel itself further into the solar system. Launched just weeks apart in 1977, Explorer 1 and Explorer 2 were initially tasked with exploring Jupiter and Saturn. They successfully observed these gas giants and made historic close-up observations of Uranus in 1986 and Neptune in 1989. Rather than concluding their missions, the resilient Explorer spacecraft set their sights on a more ambitious goal: deep space exploration. Now, 46 years later, Explorer 1 and Explorer 2 continue to travel, gathering crucial scientific data from the far reaches of the universe. They have been our primary source of information regarding the heliosphere, a protective bubble surrounding our solar system, acting as our primary messengers and relaying valuable insights about this celestial shield. In 2018, Explorer 2 entered this vast region, located 17.7 billion kilometers from the Sun. NASA's Explorer missions have provided significant insights into interstellar space, including the revelation that cosmic rays are 3 times more intense beyond the heliopause compared to within the heliosphere's protected zone. NASA scientists have integrated data from subsequent missions with observations from the explorers, creating a comprehensive understanding of our Sun and its complex interactions with surrounding interstellar space. In 2019, Explorer 1 detected a low-frequency hum that corresponded to vibrations in trace amounts of gas floating in the vast emptiness of interstellar space. This surprising discovery has raised questions about our understanding of the universe and our place within it. The outer edges of our solar system are exhibiting unexpected behavior at the heliopause, which serves as the boundary between our Sun's influence and the space between stars. Scientists have noted this phenomenon over the past decade using data from Explorer 1, Explorer 2, and NASA's Interstellar Boundary Explorer satellite, providing direct measurements of vast distances even at a specific point in existence. Recent analyses have challenged previous understandings of the heliopause, revealing odd enhancements of energetic particles in 2014 that suggested anomalies at this boundary. However, these inconsistencies did not align with existing models, leading researchers to observe significant shifts in the heliopause's position over short periods. These findings help explain why Explorer 1 and Explorer 2 entered interstellar space in 2012 and 2018, respectively. These discrepancies are not only puzzling but also contradict what scientists believed they understood about the heliopause. Researchers have termed these discrepancies as entry anomalies, indicating they are perplexing and could spark debate among mainstream scientists. NASA's upcoming Interstellar Probe mission, set to launch in 2025, promises to unveil more mysteries about the outer regions of our solar system. In May 2023, Explorer 1 experienced an unusual event during routine operations when its Attitude and Control System (ACS) began sending back confusing data instead of the usual status reports on the spacecraft's health and functionality. The information appeared random or lacked coherence. NASA swiftly identified the issue and determined that the ACS was using a passive computer for data transmission. The agency is actively investigating to prevent similar incidents in the future. Having explored interstellar space for over a decade, outside the protective magnetic field of the Sun, the Explorer spacecraft, which have been on an incredible journey for nearly 50 years, have been navigating through an environment filled with high levels of radiation. These historic spacecraft have traveled vast distances, venturing into unknown realms and uncovering extraordinary data, despite their mechanical limitations. NASA has successfully maintained their functionality by sending software updates across enormous astronomical distances to ensure their continued operation. The Explorer missions have made an indelible impact on every celestial body they encounter, offering significant insights into the mysteries of our solar system. They have discovered fascinating details about Jupiter, Saturn, and Jupiter's moons Io and Triton, including the identification of nitrogen geysers on Triton that erupt at temperatures as low as 40 degrees above absolute zero on the Kelvin scale. These discoveries continue to contribute to our understanding of the universe and its many wonders. The revelation continues to unfold today. Both Voyager 1 and Voyager 2 are still communicating with NASA's Deep Space Network, receiving commands and sending valuable information back to Earth. The plan is to continue interstellar exploration for another 5 to 6 years, but by the mid to late 2020s, the scientific instruments on these spacecraft will be turned off, leaving them silent and inactive. Nevertheless, Voyager 1 and Voyager 2 will continue their grand journey, eventually drifting past other star systems and leaving behind a lasting legacy as the first human-made objects to enter interstellar space. Their ultimate mission represents humanity's unending quest for knowledge and our desire to push the boundaries of exploration. Launched in 1977, the Voyager spacecraft were designed to capitalize on a unique planetary alignment that occurs approximately every 175 years. This alignment allowed them to embark on a remarkable tour of the outer planets, using gravitational assists to propel themselves farther into space than any previous spacecraft. This technique, known as gravity assist or slingshot maneuver, effectively harnesses the gravity of planets to accelerate, enabling the spacecraft to travel further into the solar system without additional fuel. Both Voyager spacecraft were equipped with a suite of scientific instruments that played a crucial role in their success. Among these were the Imaging Science Subsystem, which allowed for detailed photography of planetary surfaces and atmospheres, and the Planetary Radio Astronomy Experiment, which studied radio emissions from the planets. The combination of these instruments provided a comprehensive view of the outer planets and their moons, revealing details that were previously unknown. One of the most surprising accomplishments of the Voyager missions was their contribution to our understanding of planetary ring systems. Voyager 1's flybys of Jupiter and Saturn delivered detailed images of their rings, revealing that Saturn's rings are composed of countless tiny particles ranging from millimeters to meters in size. The spacecraft also discovered that Jupiter has a faint ring system made up of fine dust particles, a surprising finding given Jupiter's less conspicuous rings compared to those of Saturn. Voyager 2's journey through the outer solar system was equally significant, as it made the first close-up observations of Uranus and Neptune, the two most distant planets from the Sun. Voyager 2's encounter with Uranus revealed its unusual tilted axis and provided the first detailed images of its moons, including Miranda, which exhibited dramatic surface features like canyons and cliffs. The spacecraft's flyby of Neptune uncovered the Great Dark Spot, a massive storm system akin to Jupiter's Great Red Spot, and provided evidence of Neptune's dynamic atmosphere. In addition to planetary discoveries, the Voyager missions have significantly enhanced our understanding of the heliosphere, the bubble-like region of space dominated by the solar wind that surrounds our solar system. The heliosphere acts as a protective shield against cosmic radiation, and studying its boundaries has helped scientists understand how the solar wind interacts with interstellar space. Data from the Voyagers have shown that the heliosphere is not a smooth, round shell but rather has a complex shape with varying densities and regions of differing thickness. Voyager 1's crossing into interstellar space in 2012 marked a historic achievement, making it the first human-made object to enter this mysterious region. The spacecraft's instruments have been able to measure the density and temperature of the interstellar plasma, providing crucial information about the environment beyond the solar system. These measurements have revealed that the interstellar medium is more turbulent and varied than previously thought, with regions of higher and lower density affecting the movement of interstellar particles. Voyager 2's entry into interstellar space in 2018 further expanded our understanding of this distant realm. Both spacecraft have provided invaluable data that have helped researchers piece together a more complete picture of the transition from the solar wind-dominated region to the interstellar medium. This information has been essential for understanding the heliopause, the boundary where the solar wind slows and merges with interstellar space, and for developing models of how this transition impacts cosmic rays and other particles. The legacy of the Voyager missions extends beyond their scientific achievements. Each spacecraft carried a golden record, a message to potential extraterrestrial civilizations. This record contains a variety of sounds and images that depict life on Earth, including greetings in multiple languages, samples of music from different cultures, and photographs of human life and our planet. The Golden Record serves as a symbolic testament to human curiosity and our desire to communicate with any intelligent beings in the cosmos. As the Voyager spacecraft continue their journey, they not only transmit scientific data but also act as ambassadors of human exploration and ingenuity. Their voyage through interstellar space is a testament to human perseverance and the quest for knowledge, showcasing our ability to send instruments to the farthest reaches of the solar system and beyond. The data they send back enrich our understanding of the universe and inspire future missions to explore new frontiers. NASA's ongoing efforts to maintain communication with the Voyager spacecraft reflect the agency's commitment to exploring the outer realms of space. Despite the vast distances and technological challenges, the Deep Space Network continues to receive and transmit information, ensuring that the legacy of the Voyager missions endures. Each new discovery from these distant probes contributes to our collective knowledge and underscores the importance of space exploration in answering fundamental questions about our place in the universe. In summary, the Voyager missions have been monumental successes in space exploration, providing unprecedented insights into the outer planets and the boundaries of our solar system. The data collected by these spacecraft has not only expanded our understanding of the planets and their moons but also shed light on the nature of the interstellar medium and the heliosphere. The Voyager spacecraft embody the spirit of exploration and curiosity that drives humanity to investigate the universe, leaving a lasting legacy for future generations. The prospect of extraterrestrial life on two of Jupiter's moons, Europa and Ganymede, has generated significant interest in scientific circles. These celestial bodies may harbor conditions favorable for life, making them prime candidates for further exploration. In the mid-1990s, Carl Sagan proposed a revolutionary perspective on our solar system, inspired by the iconic Earthrise images captured during the Apollo program. This shift in viewpoint allowed us to appreciate our planet from an entirely new angle. Fast forward to August 25, 2012, when the Voyager 1 spacecraft made history by entering the interstellar medium, a staggering 11 billion miles from the Sun. Remarkably, it continues to relay vital data back to Earth. Voyager 2 followed suit in 2018, and the distances have become so vast that it now takes approximately 22.5 hours for a signal traveling at light speed to reach Voyager 1, while Voyager 2 requires nearly 19 hours. NASA's Deep Space Network, comprising strategically placed tracking facilities around the globe, ensures continuous communication with the Voyager probes as they journey deeper into space. As they move farther away, their signals weaken, yet they continue to provide invaluable insights into the mysteries of our solar system, offering a fresh perspective on our place in the universe. The Voyager mission represents a remarkable milestone in celestial mechanics, originating from Michael Minovich's discovery that spacecraft could gain speed through gravitational assists from planets to escape the Sun's gravity. Gary Flandreau demonstrated that missions launched in the late 1970s and 1980s could use this technique to reach the outer planets more efficiently, making Neptune accessible in just 12 years instead of the anticipated 30. Although NASA had to scale back the ambitious grand tour of the outer solar system due to budget constraints, they instead opted for a more feasible mission to Jupiter and Saturn, totaling approximately $1 billion. The twin Voyager spacecraft were equipped with advanced instruments, including cameras, infrared and ultraviolet spectrometers, particle detectors, a photopolarimeter, and a magnetometer powered by radioisotope thermoelectric generators. Initially designed for a 5-year mission, the probes far exceeded expectations, extending their operational lifespan tenfold. The Voyager mission has evolved into an extraordinary exploration of the outer planets and beyond, blending science and imagination. The stunning images captured by these spacecraft have turned the mission into a legendary journey into the unknown. Each Voyager carried a unique phonograph record filled with images, music, and greetings in 55 languages, serving as a cosmic message to any intelligent life forms that may exist in the Milky Way, a glimpse of human culture and our desire for cosmic connection. For over a decade, NASA's dedication to the Voyager program has allowed humanity to unravel the mysteries of the cosmos. These missions have not only provided critical insights into our solar system but have also revealed the enigmatic nature of space beyond our sun. Engineers at NASA combine creativity and ingenuity to develop software updates for the spacecraft, sending new commands directly to their onboard computers, essential for the probe's continued success. These updates address various challenges, from troubleshooting malfunctioning components to managing memory issues. The Voyager missions were more than routine explorations. They sparked a series of interstellar adventures, leading to historic discoveries and inspiring further research into the unexplored realms of space. Voyager 1 and 2 significantly advanced our understanding of Jupiter, generating excitement at NASA and prompting the launches of two major missions: Galileo in 1989 and Juno in 2011. Voyager 2 also made notable contributions, laying the groundwork for investigations into the ice giant planets within our solar system and distant exoplanetary systems. NASA has continued to build on the legacy of Voyager with ambitious missions like Dragonfly, which aims to land on Titan, Saturn's largest moon, in 2034, and the Europa Clipper mission set to explore Jupiter's moon Europa, initially observed by Voyager in 2030. Additionally, the National Academy of Sciences Planetary Science Decadal Survey proposed a $4.2 billion mission to Uranus, which includes an orbiter and lander in the 2040s, marking a significant venture into the mysterious ice giant and its moons. The Voyager missions have ignited a lasting curiosity and opened the door to future explorations, furthering our quest to understand life beyond Earth.